We are now on page 60, and to give you a little background, we're wondering how do we determine from a series of data whether we can determine if something is a function. Well, the answer is, in order for something to be a function, the x element of something can only be used once in a series of items. So let's take a look at number 1. Can this be defined as a function? Well, let's look at the x elements. 4, 2, 1, 0, negative 1, negative 2, negative 4. Is the x element only used once in a series of relations? And the answer is yes. So this is defined as a function. All right, let's look at number 2. X, the values, 3, 2, 1, 0, negative 1, negative 2, negative 3. Are the x elements used more than once? No. So this is a function. Now looking at number, did I do 3? No, let's do 3 here. This strange numbering here. Are the x elements used more than once here? Nope. So this is a function. Now when we look at number 4, we see it in a little different relationship. This is actually a graph. And it's going to look a little bit like this. And the question is the x elements used more than once? Well, as you go along here, the x elements are used only once, and this line never quite reaches a middle line here, this vertical asymptote. So the answer is, for something like this rule does define a function, because the x elements are only used once. Whatever you put in there for x is only used once. So this is a yes. And as we look at example 5, again, you would put a value in there, but you wouldn't keep repeating the same value. You only use the x value once. So this defines a function. The x element is only used once. Now as we go on to page 61, determine the domain of the function and write your answer using interval notation. Well, the basic rule that we would use here is, keep in mind that we can put anything over 1, and since there is no variable of x in the denominator, no value of x would make this value undefined. So this function defines a function. It is a function, and the domain of it, I should say, is from negative infinity to positive infinity. That is all real numbers. And looking at number 2, would any value of x make the denominator, which is a 1, a 0? And the answer is no. So for number 2, it is the same. From negative infinity to positive infinity. That would be the domain of this function. That is, values of x could be any or all real numbers. Now in example 3, we start to see there's going to be a restriction. In order for something under the radical sign, you can't have a value here that is a negative number. These are not real numbers. So the lowest value you can have for this under the radical sign, the radicand, is 5 minus x has to be greater than or equal to 0. This is the way you find what your domain would be. So all values under the radical sign have to be equal or greater than 0. So we just solve this by transposing the x to the other side and then writing it this way. X is less than or equal to 5. Now, if a number is greater than 5, let's put that in here. Let's say 6. We have the square root of 5 minus 6. Any number greater than 5 is going to give you a negative value under the radical sign. So those values are excluded from the domain. So the answer then, what would this be? And if we did this on a number line, it would look like our 5 is there, and its x is less than or equal to, so we use a bracket, and we draw our arrow this way. Now you might say, how come all these negative values are involved? Because of this negative sign right there. Any value of x that is negative, by saying the opposite of a negative makes it positive. So in interval notation, this would go from out here is negative infinity up to 5, and 5 is included in the set. Now for number 4, again, we can have a denominator now that would make this function undefined. That is, make the denominator a 0. So we solve it in a similar way. We take our denominator and say x plus 7 equals 0, and we get then x equals a negative 7 as we transpose that 7 to the other side. So if x were a negative 7, let's check it out. Negative 7 plus 7 makes our denominator a 0. So that value needs to be excluded from the domain. So what do we have? Well, you can have any real number, so all numbers on the number line, but when you get to 7, you cannot include 7. So we darken this, and this would be the number line graph of the domain, but they wanted an interval notation. So it's going from negative infinity up to just before 7, a negative 7, and then we use a parenthesis to indicate that negative 7 is not included. Here 5 was included, we use a bracket, and then we use a union symbol, and then starting on the other side of negative 7 going to positive infinity. And I see another little error. They forgot the negative signs in the answer key. All right, let's go on to our next one. Now let me set this up for you. So in our numerator here, we see that if we set it up to equal or greater than 0, which is what we've done, and solve it, we get x is greater or equal to -4. Now, here, we had to factor our denominator and then solve for the solution what values would make our denominator a 0. Well, here it would be a -4, or x cannot be a -7. Those values would make this denominator a 0, so these are excluded. So in putting what we have here on a number line, just to start to sketch it out, we're saying that x cannot be a -4. So we put a hollow over -4. X cannot be a 7. So we put a hollow over 7. Now we also know, due to the top, that x has to be greater than or equal to -4. Well, we've excluded it to be equal to -4 because of this. So to start to graph that, it can't be any of these down here. That would make this an imaginary number or not defined. So those are excluded from the domain. So we're going to start with a parenthesis here at -4, go up to just before 7, put a parenthesis there, a union symbol, and then go from the other side of 7 up to positive infinity. Now this is not quite what they have as in the answer key, but I think this is correct because we can darken this in here and then darken this in there. But because of this radical up here, we can't have negative values underneath that. And where normally you could include a 4, a -4 there, this is excluding it down here. So I believe this is the correct answer. To actually do some substitution and then find the functions where we're going to replace our x value here with the s. So this one is rather easy, and we're just going to put an s there, and that is for number 1. Now they also want us to replace it with a k, a -k, so we put a -k where the x is. And it's just that simple. Now for number 2, they're asking us to replace the x with a 0. So right there we put a 0, and then this becomes the square root of 2. So again, rather easy. So when we replace our x with a -10, it looks like this, being careful that there's a negative sign there already. So this makes this a positive. So this will equal the square root of 12, which we know from a previous lesson is the square root of 4 times the square root of 3, which is 2 the square root of 3. Okay. And number 3, it's a little tricky, because here they're saying that y equals a -2. This is your outcome already. So it must come from a standard form equation in which it's 0x plus y equals 2. So whatever value for x that you're going to put in there, and they're saying these values, it's always going to be that y equals 2. So for each of these would be a -2, I should say, yes. This one's a little tricky. Now, for these, we're just going to substitute into our radical expression the value they give us for x, which will be 6 here. And this would then become the square root of a -3, which is not a real number. And then in the next one, it'll be the square root of 3 minus 2.2, which will give us the square root of 0.8. And they do want us to get it out of the radical, so we use our calculator, and it's approximately this. And then looking at the answer key there, where this is not a real number, this is an imaginary number, they're describing it as not defined. Okay. As a study aid, and you could do this for any of them, remember we did use T-charts to help organize our data. So here we're replacing the x value with a 9, the x value with a 4 in this rule, this function. So we would go 3 times 9 squared minus 12 times 9. You want a nice way to indicate and watch your everything here. This will be 3 times 81 minus equals 135. And then doing the next one, this will be 3 times 4 to the second power minus 12 times 4. Well, 4 squared is 16. 16 times 3 is 48. And 12 times 4 is 48. So this gives us a 0. Okay, this is long enough, I think. We'll wrap this one up and then continue in the future.